But the total energy of an electron in the valence state and the conduction band is called as valence bond conduction bond. The difference in energy gap between conduction band and valence band is known as energy gap. The difference between conduction band and valence band is known as energy band. Is known as energy band. Represent insulator and conductor and semiconductor with an energy band diagram. Conductor. A device which it is a type of material in which it is a type of material. It is a type of material in which valence bond and conduction bond. It is a type of material in which valence bond and conduction bond valence bond and conduction bond overlapping with each other with energy of nearly about zero. Okay. Then it passes current and electricity through it very easily, and this type of material are known as conductor. And these majorly metals are used in conductors. Okay, and the energy is equals to this by this, and this. Insulator. It is a type of device, it is a type of device in which we. It is a type of device in which uh, the energy gap between the conduction band and valence band is near about is more than 3 electron volt. It is known as insulator, and it has is known as insulator, and uh, it does not allow electricity and heat and any type of energy to pass through it. Majorly, so these are known as insulators. It is a type of devices having energy gap between the valence band and conduction band. Energy gap is more than three. Okay. So the electron of this type of material, cannot move. This type of electron cannot move from valence electron to conduction electron. Okay, valence shell to uh, conduction shell in normal temperature. Okay, it is a type of material. It is a type of material which having energy gap more than 3 electron volt. It is a type of material which having uh, energy gap more than 3 electron volt, and these does not allow electrons to move from one valence state to conduction state in at a normal temperature. In energy like heat and electricity cannot pass through it. Okay, and difference of a 3 electron volt. Semiconductor is a type of material. Semiconductor is a type of material whose the energy gap between valence band and conduction band is near about is between 0 to 3 electron volt. Okay, 0 to 3 electron volt. So the electrons of this type of semiconductor move from conduction band to valence band easily at a normal temperature, and conduct energy like heat, electricity, etc. Generally, elements of silicon group 13. Generally, elements of Generally, elements like silicon and germanium uh, generally silicon and germanium are used for generally silicon and germanium are used for used as a semiconductor. Okay, energy here between these two are 0 to 3. Intrinsic semiconductor is a type of material which is made up of intrinsic and extrinsic. Intrinsic are the pure semiconductors which have no impurities and their conductivity is low. Okay. Uh, and extensive semiconductor. It is a type of semiconductor in which 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 dopants are used in extensive semiconductor. Dopants like say arsenic, bismuth, antimony, phosphorus, germanium, etc. Okay, so in this say number of electrons equals to number of holes. Intrinsic semiconductors number of electrons equals to number of holes, and number of electrons equals to number of yeah. And here number of electrons not equals to number of holes. Here conductivity is low, here conductivity is high. No conductivity. It is a type of semiconductor which is p-type N-type. N-type, it is a type of semiconductor where pentavalent impurities are added. It is a type of it is a type of okay. It is a type of semiconductor where pentavalent impurities are added. And p-type, it is a type of semiconductor where it is a type of semiconductor where which is developed by adding trivalent impurities like trivalent like phosphorus, gallium. Okay, and then enter impurity here arsenic, bismuth, antimony. Okay, then here in n-type number of electrons greater than number of holes, and number of electrons less than number of holes. Here majority charge carriers are electrons and majority charge carriers are the majority charge carriers holes and majority charge carriers holes and electrons are less, and here electrons and holes. So in p-type there are holes, in n-type there are electrons. PM mentioned that what is different? PM mentioned that depletion region and direct potential. It is a type of device where P and N-type semiconductors are combining from PN junction where electrons from P-type move from electrons from N-type move to P-type, and where holes move from N-type to P-type and electrons move from P-type to N-type. It is the region formed both either in either side of the junction. It is for division region. It is for it is junction. No, it's a depletion region. It is a region formed by PM junction where the p-type and n-type, where the p-type and n-type semiconductor, where the p, the region is formed on both sides of the junction, where the majority charge carriers, due to the diffusion, it is a region formed by the from either side of the junction where diffusion of majority charge carriers takes place. Is known as diffusion area. Barrier potential, the potential difference between the barrier potential. Formation of barrier potential. Okay. At PN junction of electron, अच्छा barrier potential at अच्छा formation of barrier potential. The region is APN junction is formed by the APN junction is formed where no free electrons are added. The PN junction is formed is PN junction holes move from p side to n side and electron move from n side to p side. This way, accumulation of charges takes place. Accumulation of charges takes place at either side of the junction, at either side of a junction, and it stops further diffusion. This region is called potential variation, and the potential difference across the barrier is known as potential, and the potential difference and the potential drop across the barrier is known as potential variation. Okay.